Hi everyone. So today we will go back to the first chapter of P2 and P3, which is on algebra. So the first section of this particular chapter is on the modulus function. So this is quite a new concept, especially on how you would need to solve the modulus equation. So I will just go very slowly on this particular chapter. So what is a modulus function? So basically, modulus function, you can say that it is a piecewise function, whereby you are noted by two straight lines surrounding some values of x. So when your x is greater or equals to 0, you take the value of x. If your x is a negative value, then you multiply with a minus sign. So in other words, you basically take the positive part of x. It doesn't matter whether or not x is positive or negative, you just take the positive part. Alright? So if let's say you have modulus of minus 3, you would get the value 3. So sometimes we call this value of 3 as the absolute value. So the modulus satisfies a few properties. For example, if you have modulus A equals to modulus B, so what does it mean? It doesn't mean that A equals to B because A might be a negative number, but B might be a positive number. So instead, this means that A squared equals to B squared. Because when you square the value of A and B, basically you just get the positive part of the number. So the second property is that if the modulus of A is greater than the modulus of B, then it does means that the A square is greater than B square. However, if you have modulus of A smaller than the modulus of B, it doesn't necessarily means that A square is smaller than B square. Here you need to be slightly careful because you can't let B equals to 0. So provided B is not equal to 0. If B equals to 0, then this is not true simply. So the reason why is because, like for example, say you have, okay, so why B cannot be equal to 0? So if let's say your A is 2, B is 3. So 2 is smaller than 3. It does make sense. Let's say A is minus 2. Minus 2 square is smaller than 3 square. So this also makes sense. But if let's say B equals to 0, then when you modulus the minus 2, you get 2. Then you contradict the inequality part, which is why B cannot be equal to 0. So for the first section, we will basically make use of the first property. This one. Whenever you see a modulus of A equals to modulus of B, or modulus of a certain function equals to the modulus of another function, usually what would you do is to square both sides and then solve the equation. On rare cases, you would break the modulus function down into some into the piecewise function. Then you solve for the solutions. But when you use this particular method, you need to be careful that some of the answers might not fulfill the modulus equation. So we will look at these kind of situations when we start plotting out the graph of modulus functions. So let's look at some examples. So let's say you have modulus 2x plus 7 equals to 3x. So over here probably I will just do two ways. So one of the way is to use the one circled by the red. You square both sides. So 2x plus 7 square equals to 3x square. And then you solve for the equation. So left side you have 4x square plus 28x plus 49 equals to 9x square. And then you simplify the equation. You get 5x square minus 28x minus 49 equals to 0. So then you try to find the factors. You will have 5x square over here minus 49 minus 28x. 5x plus 7 x minus 7, 7x minus 35x over here. So in the end you will get 5x plus 7 multiply with x minus 7 equals to 0, or x equals to 7 or minus 7 over 5. So remember, always you need to check for your answers, because one of the solution might not be the answer. So how do you check it? So basically you substitute back. So 2 times 7 plus 7 equals to 3 times 7. This is correct. So the second check is basically 2 times minus 7 over 5 plus 7. This is not equals to 3 times minus 7 over 5. So this inequality shows that this is not a solution. Therefore, x is equals to 7. So whenever you do all these equations, make sure you check for solutions. So now let's look at the second example. Modulus of 2x minus 5 equals to modulus 1 minus x. So you can square both sides. And then expand both sides. Then finally simplify everything. In the end you get x squared minus 6x plus 8 equals to 0. So you factorize it, you get x minus 2, x minus 4 equals to 0. So x is 2 or 4. So now do the checking. 2 times 2 minus 5, this is equals to 1 minus 2, modulus of it. So this is true. The other one, 2 times 4 minus 5 equals to 1 minus 4. So this is also true. Therefore, your answer is x equals to 2 or 4. So now let's look at third example. So for this particular example, this is modulus of x squared minus 7x plus 6 equals to 6 minus x. So here you need to be slightly careful, because you can do like above, squaring both sides. But if you do that, basically it is very complicated, because you will involve x to the power of 4. So instead, it is better to use the piecewise function method, whereby you study the positive part of the modulus function. So you try to simplify the equation, you get x squared minus 6x equals to 0. So in the end, this particular equation gives you x equals to 0 or 6. So now let's leave the solution for the moment and we study the other parts of the piecewise function. So x squared plus minus 7x plus 6 equals to the minus of 6 minus x, so you get x minus 6. So in the end you get x squared minus 8x plus 12 equals to 0. X minus 2 x minus 6 equals to 0, or x equals to 2 or 6. So you have three solutions, 0, 2 and 6. So now let's test for the solutions. So if x equals to 0, so you get modulus of 6 equals to 6. This is true. If x is equals to 2, so you get 4 minus 14 plus 6 equals to 6 minus 2, which is 4. Yeah, this is true. So the third one, 36 minus 42 plus 6 equals to 0. So this is indeed true. So therefore x equals to 0, 2 or 6. So now let's look at the fourth example. Modulus of 2x plus 1 plus 2x minus 1 equals to 3. So in this scenario, you can't really square both sides out. So what you can do is to use the first method, which is the piecewise function method. So assuming the first term is positive, so you get 2x plus 1 plus modulus of 2x minus 1 equals to 3. So modulus of 2x minus 1 becomes minus 2x plus 2. So then what you can do is to use another layer of that positive part of your piecewise function. So 2x minus 1 equals to minus 2x plus 2. So then 4x equals to 3, or x equals to 3 over 4. So now let's consider the second portion of the negative portion of 2x minus 1. So you get minus 2x minus 2x plus 1 equals to minus 2x plus 2. So the minus 2x cancel off. So this is invalid. So now let's look at the other part of the 2x plus 1. So you would get minus 2x minus 1 plus 2x minus 1 equals to 3. So then you will have 2x minus 1 equals to 2x plus 4. So again, study the positive part. 2x minus 1 equals to 2x plus 4. 2x being cancelled off. So again, this is invalid. So the last part would be the negative part of 2x minus 1. So you get minus 2x plus 1 equals to 2x plus 4. So you would get 4x equals to minus 3, or x equals to minus 3 over 4. So now you need to check your answer. So when x equals to 3 over 4, you have 2 times 3 over 4 plus 1 plus 2 times 3 over 4 minus 1, and this is indeed, okay, I did not calculate that, so 3 over 2, 5 over 2 plus 1 over 2, this is indeed equals to 3. So this is valid. Now let's check for the other part. You have minus, so this time I just directly multiplying to it. So you have minus 1 over 2 plus, so that would be minus 5 over 2. So this is indeed same as 3. So this is also valid. Therefore, your answer will be plus or minus 3 over 4. So the last question for the day. If let's say you have modulus of 3x minus 2y minus 11 plus 2 square root of 31 minus 8x plus 5y equals to 0. So how do you solve this kind of equation? So essentially the first term, which is the modulus term, is a positive number. The second term, because you already put the square root sign, is also a positive number. So you cannot add two positive number and let it equals to be 0. So the only solution for this particular equation is when the first term, which is 3x minus 2y minus 11, is equal to 0. And for the second equation, which is 31 minus 8x plus 5y, is also equal to 0. Alright? So then you manage to reduce a complicated modulus equation into simultaneous equation. So from the first equation, y equals to 1 over 2 times 3x minus 11. So you substitute this into equation 2. So you have 31 minus 8x plus 5 times 1 over 2 times 3x minus 11 equals to 0. So multiply everything by 2, you will get 62 minus 16x plus 15x minus 55 equals to 0, or minus x plus 7 equals to 0. So x will be equals to 7. So from the third equation, y will be equals to 1 over 2 times 21 minus 11, so you get 5. Therefore x is 7, y is 5. Alright, that's all for today. So tomorrow we'll go further on this particular chapter. Thank you.